Okay, let's take a look on my code. Well, for this part, I'm only keeping the five features. Well, the cylinder, the horsepower, origin, acceleration, and the weight. I'm using the hue as the origin because that is a categorical feature I'm going to use to color the samples differently. And then for this size, well, it will define how large each square is going to be. Okay, and then well, let's see what we are able to find here. Okay, well, blue USA, right? And then for the USA, well, in this is that the USA really produced a lot of the eight-cylinder cars. Do you see that? Okay, and then how about the red? So red is Japan, right? And then you see on the number of the cylinders, and Japan produced a lot of the three-cylinder cars. Well, probably all the three-cylinder cars are produced by Japan, right? And then, well, if you see the horsepower against the weight, so horsepower against the weight, and you see almost a linear increase. So it is a positive linear correlation saying, well, if you have a heavier car, and probably the horsepower will be higher, right? And then how about this one? So, well, for the weight and then the acceleration, it seems that if you for the lower part, well, there are some lower weight car, and then the acceleration is also low. And then, well, it's also kind of in the middle. So for the acceleration, there's no car got so super high or super low, and that is you can see from this plot. So acceleration against acceleration, and you see the distribution for the U.S., Japanese, and the European cars. The distribution is kind of the same, right? Well, and for the U.S., well, you see the on the upper half of this plot, well, the cars with the higher weight, well, most of them are produced by the United States. Okay, and the next one we want to do a facet grid using the origin and using the MPG and then the origin. So we see the cylinder 3, 4, 5, 6, and 8. And then one of the questions I want to ask is who produced the three-cylinder car? And the answer is Japan. Japan produced all the three-cylinder cars. And how about five-cylinder car? For all the five-cylinder cars, they were produced by European. But anyhow, this is kind of a little bit surprising because I thought the number of the cylinders can only be odd numbers, but apparently I'm wrong. Well, and how about the cylinder S4? So for cylinder S4, you can see United States, Japan, and Europe, they all produce the four-cylinder cars. So for the four-cylinder cars, I don't see a big difference. But how about the six-cylinder car and the eight-cylinder car? Well, most of them are produced by the United States. Okay, and of course it was 1970. Well, this data set it's kind of old. Okay, the next thing I want to show is factor plot. I want to do a factor plot on the tip dataset again. I'm using the day as the x-axis and then the total bill as the y-axis. Say, well, remember for the day, that is for the day of the week, and we only have Thursday, Friday, Saturday, and Sunday. And we use the total bill, and we see some really low cost lunch and dinner, and probably this data is a little bit old too. And we are using the gender as the hue. So we are separating the male customers and the female customers, and we are doing a kind equals box. So we are doing a box plot. And for the box plot, well, this is how box plot work. Well, for the box, we are doing the box from the upper quartile to the lower quartile. So that is 25% to 75%. And then in the middle, we have the median. So this is for the box. So this box shows the middle 50% of the data. And then we have the upper extreme and the lower extreme, and they should be the 5% and then the 95%. And after that, if you have something beyond that, and they will be considered as outliers. Okay, and then you see there are a few outliers here, and usually they are high, and especially for the lunch, and if you are spending, well, for the meal, and if you are spending 40 on Thursday, well, this is kind of a luxury meal, right? Okay, and then for the Sunday, Saturday and Sunday, and you will see the median got a little bit higher than Thursdays and Fridays. This means people tend to spend more on the weekend compared with Thursdays and Friday because they want to treat them a little bit better. Okay, and then let's move on. The next one I want to show you is the joint distribution. And this is a joint plot, and then I'm showing the total bill and the tip. So the total bill as the x-axis and the tip as the y-axis. So of course we are expecting a positive correlation because, well, the higher bill I'm paying, and probably I also want to pay a higher tip. Okay, and I'm using the hexagons in this case. And if I want to do another way, I can do a regression. And for the regression, and I can see there is a regression line added, right? And well, and after that, and remember for this one, we can this is a positive correlation, and then if you want to, you can get the p-value. And if in the old version, I remember in the old version, and then it does show the correlation and the p-value, but somehow they got removed from this version. Okay, but I'm pretty sure you can add them back. Well, and then for the correlation, well, a positive correlation means they are positively correlated if the value of the x-axis increases, and which is the total bill, and then you are expected to see a higher y value, which is the tip. And then you also have the p-value, and by convention, if the p-value is smaller than a certain value, and then you can say there is a statistically significant correlation. So for this one, this is a really small p-value, that is 0.00000 point 0.0000067. So that is really small p-value, and then if it doesn't matter if you want to pick that as the threshold at 0.05 or 0.01, well, this p-value is going to be smaller than the threshold, so that is a strong positive correlation, that is statistically strong. Okay, so the next one, the bar plot. So for the bar plot, we are just showing a bunch of the bars, and we are using a different data set. That is how many planets a human being were able to discover. Okay, so and then we have the method we discover the new planets, how many we discover, and then we have a bunch of the other things, and we are interested in the year. So on which year was the planet discovered? And we want to show a bar plot like this. So from the 1989 to 2014-15, and then we observe the number of the planets discovered were increasing, and the peak was somewhere around 2010, and then we have a decrease. Okay, and let's see how can we do that. So we are doing a factor plot, and then we are using the year as the x-axis, and the data set is the planet, and well, the kind. So now we are using the kind as a count because we are counting how many records do we have. So we are counting the number of the records we have, and based on the year. Okay, and then we have this version, and after that we can do something even fancier, and we want to use the hue as the method. And as you can see, there are a lot of the different methods, right? So for each of the methods, and then we see at some time they got popular, and then later they are less popular, especially if you want to highlight the pink bar. Well, before 2010, the pink bar, the real velocity. That is one of the most popular way for us to find the new planets. And then, well, starting from 2000, and you will also see the green bar increases, increases, increases. So even though the pink bar is not as successful as the 2000, however, the green bar is able to pick up, so we still have a increase around the 2000. Okay, and then around the 2010. So after 2010, the story is a little bit different. Why? Because you see the decrease of the pink bar. You also see the decrease of the green bar. So it seems that using the current techniques, the most of the discoverable planets have already been discovered. So for human being, if we want to find more planets, and then we do need a new technique. Okay, so let's move on and do this exercise, and we want to do a bar plot of the car models by year and separated by origin, and you will see something interesting. Well, from in the 1970s, it seemed that the United States produced a lot more car models than Japan and Europe, and then it seemed that something happened in 1980. Well, this is what you want to produce. Okay, so again, we'll go ahead and write the code to produce this bar plot, and don't worry about the color because this image was produced by the old version of the Seaborn. And in the next video, I'm going to show you my answer, and I will do a very quick sum up. Okay, so see you in the next video.